All right, guys, for unit 6.45, excuse me, we are looking at 6.5 today. Okay, so unit 6.5. Okay, and 6.5, we are going to be talking about function.
Skip domain.
Yeah. Function operations and composition. Composition. Function operations and composition.
It's hard to clap with Batman gloves on.
Function operations and composition. So by operations, I'm talking about basically operations with functions. So like adding them, subtracting them, multiplying, dividing. Okay, so operations are just add, subtract, multiply, and divide. Okay, that's essentially what we're talking about. Composition is when you're actually doing a function within a function. And I'm going to show you with numbers and letters and all that stuff, so it'll be a little bit easier. But operations are just mathematical operators, would be add, subtract, multiply, divide. Composition is we're actually like putting two of them kind of together. So for example number 1, I want you to let f of x equal 4x to the 1/2 and g of x equal negative 9x to the 1/2. Let f of x equal 4x to the 1/2 and g of x equal negative 9x to the 1/2. So the reason, some people get a little hung up on the f and the g here, okay? That means nothing, okay? All this is basically saying is this is like equation number 1 and equation number 2. It's just giving each equation a name, okay? It's not anything special. It doesn't mean anything differently. It's just saying this is the f equation. So it's like giving a name. Same thing with the g. Yes.
So why don't they just put equation number 1 and equation number 2? Why do we have to go into confusing g of x and f of x?
Because something called a function is actually the graph of a line. So instead of saying line 1 and line 2, it's easier to just give them letter names instead of number names. Okay. So I would like you to find, I would like you to find f of x plus g of x. And the B portion, I would like you to find f of x minus g of x. F of x plus g of x and f of x minus g of x. Write this down, please.
I'm writing it in my head.
No. Write it down on a piece of paper, please. Please do not make it so that I actually have to collect every single notes instead of just the notes quiz.
No.
Pretend to write, please.
Okay,
At least have out paper so I feel as though you are.
Got no
Thank
book.
you. Happy. Thank you. Okay, so f of x plus g of x. All you are literally going to do is plug in what f of x is equal to. So the whole thing is 4x to the 1/2 plus g of x is negative 9x to the 1/2. So 4x to the 1/2 plus negative 9x to the 1/2. Okay, any ideas what can you do with this? These are essentially like terms, right? They have the same exponent. If I just gave you 4x plus negative 9x, what would you do?
Subtract.
You just combine the like terms. You'd combine the numbers in front, the coefficients. The variables at the end stay exactly the same. That is all we're doing here. We are just looking at the coefficients in front. So 4 minus 9 gives you negative 5x to the 1/2. The exponents, nothing changes. Okay, just negative 5x to the 1/2. That's it. We're just combining like terms. Yes.
What if they're different? What if one's like 1?
You're not going to have those. Yeah, if you had different exponent values, you could not combine them. So you would just leave it like that. Okay? Kind of like if I was going to ask you to do like x cubed plus x squared. You can't. You just leave it like that. Leave it in a addition problem. Same thing here. We're going to substitute. So I'm going to substitute the f equation, which is 4x to the 1/2, minus the g equation, which is negative 9x to the 1/2. make sure that you realize that this negative does not count for this negative. So 4x to the 1/2 minus negative 9x to the 1/2. Negative, negative turns to be a positive. Combine your like terms, so 4 plus 9 would give you 13x to the 1/2. That's your answer. Questions on how I did that? Just combine like terms. Okay, so that's called a function operation when you're adding things together. Now, on your homework, it is also going to ask you to state the domain for each of these. We are skipping that part.
Yes.
Okay, so any of the part on your homework that says state the domain, you can skip that. That's why it says up on the board, skip domain. Okay, so you still have to do all the problems, but you don't have to do all the parts for all the problems. Okay, also on your homework, homework is page 432, numbers 3 through 36, multiples of 3, as well as number 38, okay? Multiples of 3, I'm going to go over this with you guys, means if 3 goes into that number evenly, you do it. So start at number 3, then like 3, 6, 9, 12, so count by 3s. That's what multiples of 3 means.
Wait,
Start at number 3. I'm just telling you how to do your homework. Start at number 3, then do multiples of 3. So like number 3, number 6, number 9, 15, 18,
cool.
21.
So we only have 12 problems?
Yes.
Hey.
It's really not that bad, okay?
That was the most monotone yay I've ever heard.
Great.
Yay.
Next one. For number 2, we're going to do another operation. For example, number 2, if I tell you let f of x equal 6x and g of x equal x to the 3/4 power. Please be very careful with your handwriting here that 3/4 does not, it looks like a power, an exponent, not a number that's like in line with the x. So just be kind of careful with your handwriting there. Then I would like you to find, for A, I'd like you to find f of x multiplied by g of x. And for B, I would like you to find f of x divided by g of x. F of x times g of x and f of x divided by g of x. If we could please all put our cell phones away, that would be really nice. Thank you. So all you're going to do here is plug in again. So plug in f of x, which is 6x, multiplied by g of x. G of x is x to the 3/4. Any ideas? How would you do that? What do you do when we're multiplying something? What do I do with the bases? What do I do with the coefficients? Like the 6 and the, remember this is kind of like a 1, coefficient of 1. What do I do with the numbers in front? You multiply them. So 6 times 1 is 6. What do I do with the exponents? Do I add them, multiply them, subtract them, divide them? Add them. So what's the exponent on this x? A 1. So you are going to add 6x to the 1 plus 3/4. What is 1 plus 3/4?
That would be 7/4.
You need to change it to a common denominator. So what's 1 whole in fourths? 4/4. So change this to be 4/4. 4/4 plus 3/4 gives you 7/4. Leave it just like that. You do not have to change it back to a mixed number. That's your answer.
Mixed numbers are hard.
Yeah, we don't like mixed numbers. We
Why
like
did
to
we-
leave things in improper fractions. It just makes a little more sense
Why
right
did
now.
we even learn how to do mixed numbers then in elementary school?
Because in a lot of situations it makes more sense. Like if I was talking about $7/4, you would want to change it to be like 2 3/4 and then change it to a decimal. So it's kind of dependent on the situation. Okay, f of x divided by g of x. Literally plug things in. So f of x divided by g of x. F of x is 6x divided by g of x is x to the 3/4 power. What do you do when you're dividing powers? What are we actually doing with our exponents? Add, subtract, multiply, or divide? Subtract. Yes, you actually subtract. So something like it would be easy if you guys had 6x to the 4th or 5th over x to the 2nd. You would know that you just subtract the powers. if I throw in a fraction, all of a sudden people get totally confused, okay? It's the same thing. It's just dealing with a fraction. So here, this still is a 6, x to the 1. What's 1 minus 3/4? 1/4. That's your answer. 6x to the 1/4. So when you're dividing, you subtract the exponent powers. When you're dividing, you subtract the exponent powers. Questions on how I did that? Again, I am not worried about the domain part. You can skip that part. The domain part, no. For these, no.
So
Okay.
these are super easy.
Next one for number 3. Yes.
How do you get it down to the x to the 4? Do you do that reducing part?
Okay, so something like, if I gave you 6x to the 5th divided by x to the 2nd, that would give you 6 over 1 just reduces to be 6. X to the what power? You'd always do 5 minus 2, so it would be the 3rd, right? You subtract. Same thing here. This is an exponent of 1. That's a 3/4. 1 minus 3/4 is 1/4. Does that make sense? It really throws people off when all of a sudden the exponents are fractions. It does not change the rule about how you deal with them. Okay, division means subtraction as far as exponents go. Multiplication means addition as far as exponents go. Better? Good? Okay, number 3, I would like you to let f of x equal 3x minus 8 and g of x equal 2x squared. Okay, so these were operations that we were going over. Now we're going to go over something called compositions. Okay, so I would like you to find, for A, I would like you to find g of f of 5. So it's literally a function or an equation inside of another equation. G of f of 5. So if you were dealing with like a regular order of operations problem, we always do what's inside the parentheses first, right? We're going to do the same thing here. I want you to actually do what's inside the first parentheses, and then we're going to plug that answer into the second parentheses, essentially. So first you need to find f of 5. If I just wanted you to find f of 5, what would you do?
Plug 5 in for x.
Plug 5 in to the f equation for x. So 3 times 5 minus 18. That gives you what? Minus 8, sorry. Can't read my own writing. 3 times 5 minus 8 would give us 15 minus 8, which is 7. So we know that f of 5 is equal to 7. Now, I'm going to take this and I'm going to plug in the 7 inside here. So now I need to find g of 7, because instead of f of 5, I'm going to replace it with its actual value, which is 7. Now I plug the 7 into the g equation. So plug this in, that would give you 2 times 7 squared. 7 squared is what? 49, and 2 times 49 is equal to 98. That's your answer. So compositions are basically, you need to go from the inside out. So find what's inside and then move out. Okay, now same thing for B, but this time I would like you to find f of g of 5. Do you think that this will give you the same answer or a different answer?
Same.
Let's see. Let's work it out. This is where I'm going to prove to you that basically order of operations is actually kind of important here, okay? So g of 5 is the first thing you want to find. So g of 5, plug in 5 into the g equation. So 2 times 5 squared. According to order of operations, we have to do the 5 squared first. So 2 times 5 squared is 25. That gives you g of 5 equal to 50. Then I want you to take and plug in g of 5, or 50, excuse me, into the f equation. So now we're going to find f of 50. Plug 50 into the f equation. So 3 times 50 minus 8 to So your multiplication, 3 times 50 is 150, minus 8 is 142. So it is very important to follow order of operations. You get very different numbers when you follow order of operations. Okay? So we always work from the inside and move outward. Questions on how I did that? Now, along the same lines, now I'd like you to find the C portion of this. I'd like you to find f of 5. So you're going to plug in 5 into the same equation, then plug in that answer into the same equation. We have an advantage on this one, though, because I've already found f of 5, right? What is f of 5? 7. We already did it. Okay? You know that f of 5 was equal to 7. So plug in 7 into the f equation. So now find f of 7. We're plugging into the f equation, so it's 3 times 7 minus 8. 3 times 7 is 21 minus 8. So 13 is your answer. It's just plugging things in and making sure that you plug them into the correct equation and then follow order of operations. And then the last one for this example, we have one more example after this. D, I'd like you to find g of 5. Lots of 5s. G of 5. I've already found the inside one. What was g of 5 equal to? 50. I already found that. Now I'm going to find g of 50. G of 50, you plug into the g equation to make sure you're plugging in the right one, is 2 times 50 squared. Order of operations says I do the square part first, so 2 times, what's 50 squared? 2,500. And multiply 2 times 2,500 gives you 5,000. That's your answer. Anyone have questions on how I did that? I know this is different, but it's really just plugging things in, okay, into the correct place. Anyone still writing these? No good? Okay, last one we're going to do. Last one for number 4, and there are 3 parts. Okay, so example number 4. I would like you to, we're going to say, let f of x equal 4x to the negative 1 and g of x equal 5x minus 2. Let f of x equal 4x minus 1 and g of x equal 5x minus 2. And I would like you to find, for the A portion, I'd like you to find f of g of x. F of g of x. So we always work from the inside out. So instead of g of x, I'm going to write what? We already know what g of x is equal to. The 5x minus 2, right. So I'm going to plug f of 5x minus 2 into the f equation. So f of 5x minus 2, plug this in for x, that gives you 4 times 5x minus 2 to the negative 1 power. How would you simplify that? What happens anytime you have a negative power? What do you have to do? Make it a fraction, right? So make it over 1 and put anything attached to the negative power in the opposite side of the fraction bar. So does the 4 move? No, the 4 stays there. It is not attached to that negative power. Over, does the 5 move? Yes. Everything inside the parentheses is attached to that negative 1 power. That is your answer. Okay, that is how we simplify that. And that's your answer. I know that one's a little abstract. You'll get it. Okay. Next one, I'd like you to find g of f of x. G of f of x. So we're going to go backwards here. we know that f of x is equal to 4x to the negative 1. So I want you to find g of 4x to the negative 1, meaning I plug in 4x to the negative 1 in for x. So 5 times 4x to the negative 1 minus 2. How would you solve that? What would you do? Make a fraction. Okay, so if we make that over 1, what's actually going to move? Just the x, because it's the only thing attached to a negative exponent. So still, you're going to have 5 times 4 in the numerator over x in the denominator. Okay, it's x to the first. If you write the 1, that's fine. Then minus 2. The whole thing is not a fraction, just this one part. And then if you simplify that, what would that give you? 5 times 4 is 20 over x minus 2. That's your answer. Okay, last one. For C, I would like you to find f of x. F of x. So again, we're going to plug in basically the same equation 2 times. So you know that f of x is equal to 4x to the negative 1. Now you need to find f of 4x to the negative 1. So when you plug that in, you'd get 4 times 4x to the negative 1 to the negative 1 power. So you're just plugging into that same equation. How would you do that? What would be your next step? What does this exponent do? What do you have to do with it into the parentheses? Distribute it. It goes to both the 4 and the x. So before you move anything, we want to distribute that exponent. So you still have a 4 on the outside. You still have a 4 to the negative 1 and an x to what? Negative 1 to the negative 1 becomes what?
1.
Positive 1. Then what?
Yep, flip it.
Now we want to make this a fraction. So this 1 has to go to the bottom. Everything is still multiplying though. Okay, this is all still multiplying. So 4 and x is left in the top. In the denominator, you have another 4, and these are still to the first power. Then what happens when you have 4 over 4? They reduce each other away. So actually all you're left with here is just an x. That's your answer. I know that was a lot of work to get 1x by itself. Okay, make sure you write it down in case you haven't already. Your homework is on page 432. You are doing numbers 3 through 36, multiples of 3, and then number 38. Okay, that is your homework over the weekend. And we're done for the day.